Take 2 with balloons. Alright, we're getting the air out somehow. No, it's all escaping. That's as much as we're going to get it blown up, I'm afraid. But we all know what we do with these sort of balloons at parties, don't we? Yeah? Balloon animals, right? Alright, hang on a minute. Let me get behind here to quickly do some balloon animals for you. Are you ready for this? Snake! So you wanted more? Worm! I'm now completely exhausted my balloon animal repertoire, I'm afraid to say. But look, I should have pointed out that at Science Week, obviously when we're doing science parties, we like to use science to help. So we don't actually make balloon animals, we make balloon rockets. So this is actually a rocket, yeah? We'll see rockets. No, what will be if we give it a countdown, won't it? We need to give it a countdown. Which way do rockets go? So we're going to aim it that way. Can I get a countdown from all of you from 5? Are you ready? Here we go. 5,
4, 3, 2, 1. Blast off!
Thank you very much. Wow, that was super fast. The other one I was using wouldn't have gone that fast, but anyway. Do you know why that worked? So this is stretchy, isn't it? It's rubber. Rubber likes to stretch. When you stretch rubber and let go, what does it like to do? Unstretch. Yeah. So, when I blew it up, the air inside was stretching it, wasn't it? When I let it go, the air inside, the rubber tried to unstretch. And the only way for that to happen was to force the air out. And that causes what made our balloon fly. It's not on the yellow stage, we don't mind. Thank you. Just to the side. You all know Newton's third law of motion, don't you? No? Alright, let me give it to you in words that you might have heard before. Every action has an equal but opposite reaction, right? So in this particular case, the action was the air being pushed down by the balloon. The equal and opposite reaction was the air pushing the balloon up. That's why it flies. That's why most rockets fly, as it turns out. Newton's third law. I think there are other things I like to have at parties as well. You know what else I like? I really like to have party poppers. Who likes party poppers? Yeah. Here at Science Week we have quite special party poppers. Our party poppers look like this. A bit different to the normal party pop. For those of you who are below a certain age, this is called a film canister. Once upon a time, before digital cameras used film. This is what it came in. The lid does sit on top, obviously. So this is my party popper. All I need to do is fill it with the things needed to make it pop. So it turns out I'm actually going to use 2 components that I'm going to mix together. The first one is this very dangerous chemical in this bottle here. It's called dihydrogen monoxide. You all know that one, don't you? H2O? Water, yeah, of course. This is water, very dangerous. There it is. And the final part is Alka-Seltzer tablets. You all know about Alka-Seltzer tablets? These are things you can take when you've got an upset tummy or something. I'm actually only going to use half an Alka-Seltzer. So break that in half. Turns out when you add this to the water, it makes bubbles, right? It fizzes. And that is, I think, what we need to launch our party popper. So I'm going to drop this in the container, put the lid on, and once I place it back on the plate, I'm going to do the countdown. From 10 this time. Are you ready? Not yet. Wait till I say. And go.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
You forgot the blast off.
Blast off.
Now you've ruined it now. Come on. Blast off.
Get it blast off. Very good. Blast off. Blast off.
Wait.
Way!
Okay. reason I got it 7.5, isn't there? Obviously. We are going to do it again. But this time you're going to get it right by counting more slowly, yeah? Probably about twice as slowly by the sounds of it. And don't forget the blast off, folks. Alright. Excuse me. Alright, here we go.
Not yet, not yet.
10, 9,
5, 4, 3, 2, 1.
blast,
And 8, and
blast off.
This today I got it right. Missed it by this much.
Blast off, blast off. Hey!
We got a great catching crowd today. You notice that? Alright. Excuse me, everyone. So, it was fizzing. It was making bubbles. Bubbles full of gas. In this particular case, carbon dioxide gas, which built up inside the canister. More and more and more gas was being created, filling up the space until eventually, no more room. And when there was no more room, the lid had to come off, didn't it? The trouble is, the lid had nowhere to go. There was a table in the way. So the bottle went up. Does that sound familiar? Newton's third law of motion again. The action was the gas pushing down. The equal and opposite reaction was our bottle popper, our party popper going upwards. If you want to do this at home, I can offer 2 pieces of advice. Outside. No, seriously, it's a little bit sticky. And more importantly, if you wanted to go faster, warm water. Warm water will make it pop faster than the cold water I was using. Alright, what else do we have at parties? Well, you know what? Bubbles! Right up to the cake there, you're jumping ahead. Alright, bubbles. I love bubbles. Let us make some bubbles. Now folks, just a quick reminder what I said. Let's keep this space clear. No children are to come running out and pop my bubbles.
No, no popping up bubbles, okay? No, jangan lari ke sana. Itu pop up.
Alright, here we go. Of course, if a bubble comes to you, go for it, it's all yours. I have to say, it's a bit of fun, but honestly, I have a single rule that I go with when I play with bubbles. Go big or go home. Yeah? Don't bother with these small bubbles. Come, let's get bigger. But get rid of that silly little bubble one there and go for a bigger one.
You stop, it works.
By the way, the thing I love about bubbles is it combines 2 things I love. Bubbles and sandwiches. You know what I'm talking about, don't you? What I got on here that's going to make the bubble is in fact a sandwich. It is a sandwich of soap, water and soap. And it's that sandwich that actually makes the bubble for us when I do this.
Yes!
Sometimes I make bubbles without meaning to. You popped it before it came off. Too dry. Alright, so I don't know whether you know this, but when you make bubbles in the wild, they have 3 natural predators. Wind. Fortunately today is not too windy, so we're doing well. The second natural predator for the bubble is dry air. Bubbles dry out too quick, they pop. But the third and most dangerous natural predator of the bubble is the child. Keep bubbles away from children. They're dreadful for them. Have you noticed there's been something in common with all the bubbles I've blown? They're round. I think we need to try something a bit more exciting than round bubbles. Let's try some bubbles of this shape. What do you think? Some weird bubbles. Who thinks this is going to work? Who thinks this is not going to work? Who's not thinking at all? Thought so. All right. Let me try it out. So, starts off as a square sandwich, right? Let's see what shape bubble it gives it. That shape. Disappointing, wasn't it? Try that again. I talk too much and it dries out. So, I think it's safe to say, not very square. Can I catch it, buddy? Almost. Oh, look, I said it back to you. Can I just say, natural predator? Alright. So it seems that square bubbles don't seem to want to be square, do they? I think we need to try a different shape. Can I make triangular bubbles?
No.
Who thinks yes? Who thinks no? Who doesn't care? I'm going to try anyway. Are you ready?
Oh.
There seems to be a certain roundness about these triangular bubbles, doesn't there? Doesn't seem to be working for me. Doesn't like this side of the room, sorry. They just keep popping over here, sorry. Bang! Alright, another nap. You breed predators in your place, do you? Alright, folks, there is a very good reason for this. Remember what I talked about the sandwich? There is a reason why we need to make a sandwich to make bubbles. Can you blow bubbles in just pure water? Of course you can. Of course they pop straight away, don't they? Well, you imagine get a straw, a glass of water, you can make bubbles, can't you? Yeah. But they don't last. The reason for that is simple. Water is sticky. The thing that water really likes sticking to is water. So when water gets too close to water, it attracts and the bubble pops. The reason for the sandwich is to separate the water from all the other water. The soap keeps it apart. But if I build a shape that has a corner like this, clearly the water at the very point is close to the other water and it's going to want to pop. The only shape that is going to be stable is that shape that lets all the water get as far away from all the other water as it possibly can. The only shape that's going to allow that is the ball, the sphere, the circle, whatever you want to call it. Now folks, I did say go big or go home, so I think we need to go big. Big enough? Alright, so lots of soap. Let's make a sandwich. The big ones make the 20 minutes. We need to stay in our seats, please. Sit down on the seat. I have to stop making bubbles. Can you sit down, please? Can you sit down, please? Apparently not. Alright, folks. Oh, I've still got a bit of bubble mix left. Apparently the wind is aiming due that way. So, did we all see what was inside the bubble? Air! You could see the air, could you? No, you couldn't see the air. No, it's pretty hard to see the air inside the bubble, unless you fill it with something. How do you know why I have a smoke machine, folks? Let's fill a bubble with some smoke, shall we? There's always one.
push it up, no, push it up.
Where'd that one come from?
Smile.
I tried to get it to you.
Knee down. Alright, so as you can see,
Let me sit down.
the air inside when filled with smoke doesn't hang around after the bubble pops, does it? It doesn't just stay there sitting in a bubble shape. It tends to want to dissipate. It blows around in the wind. Now folks, I think it has come time for cake. And obviously if we're going to have cake, we need to light the candles. And what else do we need to do? Sing! Thank you. Someone knows the rules. Not yet. I haven't lit the candles yet. That's like getting them to light. We have 1,
Yeah.
2, 3. Alright, we have candles alight. Now folks, we are about to sing Happy Birthday to the Planetarium, but it's not a dirge. It's going to be a happy song. None of this. Happy birthday. No. Upbeat, alright? Sing with me. You ready, everybody? Here we go. And
Happy birthday to you. Happy birthday to the planetarium. Happy birthday to you. Hooray! Hip, hooray! Hip, hip, hooray!
hip hip.
Hooray!
You don't see any time, but you're going to do it, really? Alright, it's time to blow the candles out. And obviously we're going to need to use some science to help me with that. So I've got my air cannon. You know air cannons, don't you? Yeah, you whack it, the air comes out. Are we ready? Let's blow these candles out. Here we go. Can I do it in one go?
Oh! Hooray!
I've only ever done all 3 in one go at once. Did you see the air coming out of the cannon?
Cannon.
There we go. Let you go your hair. Obviously, we'd really like to see the spear coming out, wouldn't we? So you know what we have to add to the
Kyle,
cannon?
Kyle, you're gonna have to make one of them.
Except, I've left it on too long, it's overheating.
Yeah, you're gonna be busy
Hang
making.
on. Just going to unplug it for a
Square
second.
balloon
give it a chance to cool down.
We've done it.
This happens so often. The timing it is quite a challenge. Alright, we're good. Here we go. Are we ready, everybody?
Oh!
Should we get some more? What can be fun is if you blow a big slow one and then put a little one through the middle. And folks, that has brought us to the end of our birthday show. Thank you very much for coming along.
Hooray!